Hi, I'm Cheryl Leach. In this problem, we're going to be looking for the relative extrema of y equals x minus 2 times the sine of x on the interval from 0 to 2 pi. Well, I know that relative extrema occur when there's a change from increasing to decreasing or decreasing to increasing. So I want to find out when my function is both increasing and decreasing. We determine this by looking at the derivative. So dy dx is going to equal 1 minus 2 times the cosine of x. And when we're looking for a change, we want to know where the critical numbers are. So the critical numbers occur when the derivative is equal to 0 and when it's undefined. So I want to know when is the derivative equal to 0 and when is it undefined. Well, it equals 0 when 1 minus 2 times the cosine of x equals 0. Let's take a second, though, to talk about when it's undefined. This is a cosine function, and it's never undefined. So we won't get any critical numbers from that case. So let's go ahead and work on the case where the derivative is equal to 0. I want to first isolate the cosine of x. So I can do that by adding 2 times the cosine of x to both sides, and then dividing both sides by 2. So I now know that the cosine of x is going to equal 1/2. So that's going to relate to one of my special angles, and I have to think about which one it is. So what do you take the cosine of to get 1/2? Well, one answer is pi over 3. So x is going to equal pi over 3. But that's not the only spot. If you think about it, cosine is positive in the first quadrant, but also in the fourth quadrant. So I already have my first quadrant angle. I need an angle that's in the fourth quadrant whose reference angle is pi over 3. Well, that would be 5 pi over 3. So 5 pi over 3 is another critical number. Now, I'm only interested in answers between 0 and 2 pi, so I only have to go around my circle one time collecting answers. So these will be the only 2 results. Okay, so let's go ahead and see what I have. I want to fill in my table. I'm going to be looking at some intervals, and I'm going to break this interval up at my critical numbers. I'll start at 0, end at 2 pi, and break them up at pi over 3 and 5 pi over 3. So my first interval will be from 0 to pi over 3. The next interval will be from pi over 3 to 5 pi over 3. And then my last interval will be from 5 pi over 3 to 2 pi. The next step is to take a test point on those intervals. So let's go ahead and pick any value we like between 0 and pi over 3. So let's try x equals pi over 6. And I want to see what the sign of my derivative is at that point. So here's my derivative, and I want to take 1 minus 2 times the cosine of pi over 6. Well, the cosine of pi over 6 is the square root of 3 over 2. 2 times the square root of 3 over 2 is just going to give me root 3. 1 minus root 3 is a negative number. And my conclusion is that my function is decreasing on that interval. Okay, let's move on to the next interval. I need to pick a number between pi over 3 and 5 pi over 3. Let's try pi. Again, we're going to take this and we're going to plug it into our derivative. The cosine of pi is negative 1. So I'm going to have 1 minus 2 times negative 1. That's a positive number, which indicates that my graph will be increasing. One last interval to check. I need to pick a test point between 5 pi over 3 and 2 pi. So let's try 11 pi over 6. The cosine of 11 pi over 6 is going to be the square root of 3 over 2 again. And I know from before that that's going to result in a negative solution. And so that means my graph is decreasing. Okay, so if I interpret my information, I'm looking at a graph that decreases and then begins increasing again. So at pi over 3, I'm going to have a relative minimum. So a relative minimum at pi over 3. Now it's worth checking to make sure my function is actually defined there. And I'm allowed to take the sine of pi over 3, multiply it by 2, and then take pi over 3 minus that value. So it's defined there. So there will be a relative minimum at that point. Well, let's continue. I've been increasing now, and all of a sudden I turn around and decrease. That's going to create a relative maximum. And that happens at 5 pi over 3. And again, it's worth checking to make sure my function is defined here, but it is. Okay, so I think I have my relative minimum and my relative maximum. So what I'm going to want to do is look at a graphing calculator to see my results. So what we're going to do is we're going to enter the equation y equals x minus 2 sine x into your calculator. And then you're going to look at the graph. So I'll enter x minus 2 times the sine of x and graph it. Okay, now when I do this, the next thing I'm going to look at is I'm going to calculate the minimum value. So I'll go ahead and hit calculate. I'm looking for the minimum. Now my graph will appear and it's asking me for a left bound. So I'm going to use my arrow keys and enter a value a little bit to the left of where I think my minimum is and hit enter. Then it's asking for a right bound. So I'm going to again move that cursor over till I hit a right bound. Now it's going to ask for a guess. So I'm going to move it a little closer to where I think the minimum is and hit enter. And it's going to show me a location on the graph that says I'm at x equals 1.047 and negative 0.685. Right? So that's telling me that's what my relative minimum is. Now, my calculator is using decimals, but if you look at pi divided by 3, the decimal approximation for that is exactly the x-coordinate that my graphing utility told me to use. Now, just as something interesting to try, let's evaluate the function at pi over 3. So if you use your evaluate key and evaluate that function, you're going to get the minus 0.685. So it's going to evaluate it right at that minimum point. Now we're going to do the whole process over again for the maximum. So let's go ahead and calculate the maximum. It's going to ask me for a left bound, so I'll enter the left bound. It's going to ask me for a right bound, so I'll toggle over till I can enter a number a little bit to the right of my maximum. Then I'll take a guess. Again, toggle over to something that's close to the maximum and hit enter. The graphing calculator comes up with the point 5.24 and 6.97. Right? Well, again, if you get a decimal approximation for 5 pi over 3, it will be 5.24. And so it's telling you that the maximum value happens at 6.97. Again, just as kind of a test, let's evaluate the function at 5 pi over 3. So if I evaluate at 5 pi over 3, I'm going to get my 6.97 result. I hope this was helpful. Thanks.